Hello there, it's Jay here from Jay's Vintage Junk, and if you haven't guessed it already, we're going to see if we can get this chassis from the wartime civilian receiver up and running in this video. The cabinet at the moment, if you remember from the previous video, there was a few wooden blocks that were loose in the cabinet. When I actually took a proper look at the cabinet, the whole base was actually loose on it, so basically I took the base off it, cleaned all the old glue off, reassembled it with some fresh glue, re-glued all the wooden wedges and everything that's down in my woodworking workshop at the moment, just setting off, so that's all ready to go once we've got the chassis back up and running. So that's what I thought we'd do in this video. Now we've got the chassis, we've got the rectifier valve that we took out of there just while we was manipulating the chassis in and out of the cabinet, but I did have a look through all my spares and I have managed to find a EL33. Now this is the output valve that should be in this radio. There are various output valves from the era which would work in here. It should actually have, like I said, an EL33, but they use the was it the British Valve Association, BVA abbreviations for all the original valves that were fitted to these wartime civilian receivers, so it would have had a different designation to that, even though basically inside I think it was an EL33 in most, if not all, of the wartime civilian sets, because there was quite a few manufacturers of these. We might even, if we're really lucky, I did have a quick squiz over it earlier but I couldn't find it, but we will have a look in a bit more detail and see if we can find the code on here which will tell us who actually made this version of it, because I think there was about 20 different manufacturers that all made this radio, all to exactly the same specification, or near as damn it to exactly the same specification. Like I said, and they were these wartime civilian sets. I was slightly wrong on the date as well in the previous video. I said this came out in 45. It didn't. It actually came out in June 44. So still, you know, while the fighting was still going on, basically. But really was towards the end of the Second World War, and I believe these were still being made up to something like 46 or 47. And there are some adverts from the early 1950s, like 51, 52, in like the back of radio and TV servicing and stuff like that, selling brand new one of these as surplus, and they're like £3.50 or so. You know, they're a lot cheaper than any other set. And in fact, there was loads and loads of articles published in things like Practical Wireless, how to add long wave to these, so you know, basically turn them into more of a proper set with long wave and medium wave. Neither of the sets that I've got have ever been attacked though. They've not been butchered in that way. They are still exactly as they would have been from, you know, the Second World War. Right, what are we going to do then? Well, one thing I have got, this is the first sheet of the trader sheet for this actual set. I haven't got the entire thing. One thing, I've got this myself on a CD somewhere and I can't for the life of me find my CD with it on. So I printed this off of radiomuseum.org, which is a good resource, but I'm not a member, so you can only print 3 downloaded sheets per day, and up to like 10 a month or something. The whole trader sheet for this is like 5 sheets. To be honest, I don't think I need the rest of it. This is what I want, is the circuit diagram. I think for what we want to do with this set, and it is a very simple set really, it's medium wave only, it's only 1 wave band, it's a fairly simple circuit. We should get away with just having this basically to work off. As we saw from the previous video, this thing has basically never really been worked on. The only thing someone's done in the past is replaced the mains lead with a modern mains lead. I'm starting to think that even those capacitors there are actually original. We'll get into that when we actually look. We probably will be changing those. What we actually change, the rest in the radio actually is kind of going to depend on what we find. As you know, my end game with this is to convert it to FM with that little board, so we're not that mithered about the AM side of it really working. What we want to work perfectly is the audio output side of it, but what we don't want is something in this section, you know, with a shorted capacitor in it, which is going to, you know, be pulling the HT down and causing damage or anything. So what I would like to do, like I said, is get this thing basically to work as an AM radio, and then when we get back to it and we have a look at the proper board, then look at converting it to FM. Well, because it's got a plug on, and like I said, this came from a collector, I have a feeling this probably was in full working order when it was put away. I'm going to connect the lamp limiter up. We'll put the valves in which are missing. In fact, what we could do, what we could do before we did that, put the rectifier valve in, and because this is a parallel fed set, as in all the heaters are in parallel, apart from the rectifier actually, because that uses a completely separate valve filament than all these valves do, but all the 6.3 volt valves there are all fed in parallel, so if we pull one out we can still run the rest of the set. So I'm going to run the rectifier up. Basically what I want to find out is, have we got any leaky capacitors in like the audio section. Basically we're going to go around the radio just with the rectifier powered up and see what's actually working, see what's good and what's not, as a first start off. If we're reasonably happy then, and we've not got like major leakage on the grid of the output valve or anything, we can put the output valve in and we'll see what it does from there. From there on, then we'll see and have a look at what we're actually going to change in this to kind of like get it ready for what's going to happen to it in the future. Right, let's get the old lamp limiter in. There we go. And we will still power it through this. It will drop the voltages slightly, but just in case, like we've got a short in there, or we've got a capacitor which is dead short across something, this will save any flashes and bangs and pops and everything, and will give us a complete visual indication that there's definitely something wrong. Right, so we will, we're off now. We'll put the light in circuit, plug in there, we'll switch the radio on. Get the rectifier valve plugged in. We'll leave them two valve in, so we've just got some load on the 6.3 volt winding basically, so the transformer is actually doing something, it's doing its job on both the HT and the LT sections of it. What we're not going to put in is the output valve for now, because like I said, we want to do a little bit of observation. Radio's on there, I've got it switched off there, so I'm going to switch it on. We'll probably see that glow a little bit, and hopefully we'll see the valve up there, the rectifier valve, start to light up. If nothing starts to smoke, that doesn't start to get brighter, like ridiculously bright or anything, we'll power back off and we'll get this set up so we can actually get the meter connected up, and we'll take some voltage measurements underneath. And basically from what we find there, we'll decide where we're going to go next. So let's just switch on first. And so we've got a little bit of a flash on there and it went straight out again. Now you can see we've got a little bit of filament light in there. That's capacitors basically charging. That's looking pretty good actually. Just seeing a little bit of a glow on the filament there is absolutely fine. That's a 100 watt, but oh, it's a 60 watt bulb I've got in there at the moment. That's absolutely fine, that. Right, we'll switch off. And we will make sure we can get this in a position where we can get to everything and definitely not damage that rectifier valve. We'll turn that like that. Can you see it? Let me get you down a little bit. If I drop you down a bit and kind of get you like that, and zoom you in a touch. There you go, you can kind of see what I'm doing now, and then I can get my meter in shot. You can see that, hopefully. Hopefully you can see that. Let's get that over onto 500 volts DC. We'll switch that on. I'm going to use the red lead there. I'll take a plug-in probe as well. We'll plug that in. In fact, let's get rid of that. Let's plug that in there. We can clip that to chassis now. There we go. We've got a good connection to chassis there. So while we're taking all our voltage measurements, basically we're just using this probe here. So we can touch on something, we can take a measurement, and we're only ever using one hand. This hand can disappear, you can sit on it basically. This is the safest way to work, because obviously we have got high voltage here. Goes without saying, if you're not confident to work on stuff, you know, that's got a couple of 100 volts DC in it, you know, enjoy this as entertainment. Don't, you know, don't try and replicate what I do. Little bit of a disclaimer. I don't generally put disclaimers in stuff, but it's, you know, it's how stupid people are nowadays. Right, we will switch back on again. We've got a little bit of a glow on there, so we know that we've got some voltage in here. Now the voltages aren't going to be right because we are running through the safety lamp, but what we can do is, like, we go onto this smoothing can here. Got 209 volts there. Our HT should be around about 250, so obviously, like I said, it's out of circuit at the moment. That is reducing it somewhat. Let's just get on that one there. There we go, 237 there. That's looking good. Let's try and get on this one here. There we go, we've got about 150 I think we got on there. Right, one thing I want to check is this capacitor here. This is what we refer to as that capacitor. I get my get the circuit diagram here. It's basically going to be somewhere that's got HT on it. So we're going to be looking around about, you know, C14 there, because that's going to basically, that's the volume control, and that's onto the grid of the output valve there. So if we have a positive voltage on that side of that capacitor, it's going to damage the output valve, potentially damage the output transformer. So let's see what we've got up here. We don't actually seem to have much of a voltage there. Although this circuit is a little bit weird because it uses that West detector. So perhaps we don't have as much HT up that side of the circuit. Let's see what our HT is on the 163 volts there. That's fine. That's our control input there. Right, I think that's okay actually. I'm quite happy to put the output valve in, and we'll still have a little bit of a probe round and see what we've got. Now I was expecting to have HT there, but then looking at the circuit, we have the West detector there. That's why I was explaining that these are not like a standard super het radio. They don't use a valve as the detector. They use a very early kind of semiconductor basically. It's called a West detector. I'll point it out in here after. But that's there, and everything past here I think it's actually fairly low voltage. It's just rectified. So obviously you've got the RF on here. The West detector filters it out, and you've just got AF coming out into this part of the circuit. So I think actually, providing everything around here is okay, we should be alright. These are the capacitors that we've just been checking, C18, C17 and C16. Those are them big electrolytics. We'll probably have to change them because I don't think they're going to be in tip-top condition. But that's where we're getting them voltages we've just checked on. So that's where we got, you know, the 230, 215 and about 150. We've got another electrolytic capacitor there, which I think is that one there, which I don't think it's got a lot of voltage on it, if I'm right. Oh, hang on, I've got the power off, so you won't even check that, will you? Let's just let that power back up. I don't think that's got a lot of voltage on it. Alright, there we go. No. So down there we've got 200 and odd. Nope. Right, let me put the output valve in. Now we will see that that will light quite a little bit brighter than it did before, because this is actually pulls a fair bit more current than the other valves that are in there. And we should start to be able to hear some audio as well. Probably won't pick a station up until I can see if I can connect an aerial, but we should get something. Right, let's power back up. You saw that got a lot brighter then. So we just have a quick measure on here. Quick measure down here. Just got some capacitors charging up and everything there. We're a bit low. Let's see what we've got on that back capacitor there. 153. Yeah, we're very low on HT there. But we have got some audio there. No voltage there. But our audio stage is definitely working. Right, let's connect an aerial up to it and see if we get any signs of life. Let me just switch off for a second. Let's see what we've got for an aerial. I did have a roll of wire lying around here just for that purpose, and I don't know what I've done with it. I tell you what, folks, just give me a second. I could do with going grabbing a coffee anyway, so I'll see if I can find some aerial wire. Back in a sec. Right, okay, we're back. The good news is I found 2 or 3 meters of some old rubber flex, which will do nicely as a temporary aerial, so we'll connect that up. The bad news is I've run out of coffee, so I'll have to take a trip up to the local Tesco's in a bit. But never mind, we'll soldier on without any coffee. Right, let's switch back on. Right, we're in there. And let us see if we've got any signs of life now. Let's see what our HT is. Right, we've got 133 there. Let's go in there. And we've got 157. So we are very low on the HT. signs of life. See if we've got anything. We may have to actually give it the full mains and switch the limiter out just to see if we can get a station on it. Let's take that out. See what we've got on the HT that's there. Let's see, we're still low though, even though with that out there we should be closer to 250. In fact, let's try on that back capacitor there. We should be closer to 2. Yeah, that's not bad. 262, that's quite healthy. So we should have, if everything is working, we should have audio. We're not getting anything. It could be that the west. Got a dirty aerial connection. Right. There we go. There's something definitely wrong though, because that's full volume. That's Radio 5 Live, which should be quite strong here. And that's it. That seems to be all I'm... There's something up there. But let's switch that off now. So yeah, we've definitely got issues. Let's get all that unplugged and get that out of the way for now. Right. What I'm not hearing is a load of hum though, so I think even though those capacitors are really, really old and possibly... Actually, they're stone cold as well. They're not getting warm at all. That's quite impressive. Make sure those have bled down. Let's see if I can make sure I can see that. Because all capacitors, even can occasionally still hold a charge. Make sure you connect your meter right. Just make sure those are dead before I start sticking my fingers in there. Yeah, we're happy there. That's good. Get on that one there. Yeah, there's no more charging that. That's more of a thing with like solid state stuff. Generally speaking, valve stuff. Providing the circuit's there, when you turn the power off, the valves have got enough heat in the, basically heat in the filaments to pull away all what's left of the voltage for the HT voltage, and the capacitors should be fairly safe once the power's off. That's not always the case. Obviously, you've got a fault in there. You could have a capacitor that's not got anything pulling it down, and that can hold a charge for quite some time. So it's always worth your while just checking, just making absolutely sure everything's safe and sound. Right. That's not... I mean, it's hot. It's warm. You know what we told you, but that's not burning hot. Rectifier valve's the same. It's warm, but it's not absolutely burning hot. I think what we will do, just to make life a little bit easier for the time being, we're just going to disconnect. In fact, that's one capacitor that we do want to look at. That could be why we had low volume. We have a capacitor right across the primary of the output transformer there. Now if that goes short, basically it will kill the output transformer and give us very low volume. So that's one we can easily check. It's easy enough to replace as well. In fact, that's probably one we'll change first. What you can also do with that one, because it's not critical, is you can just cut it, and if the volume instantly comes back, you know that's where your problem was. What we'll do for now, we'll cut one, because we'll have to change that anyway. I'm not leaving that in circuit. Let's get the old test meter. This is not the best way of testing a capacitor, but it will be able to tell you whether there's a dead short in it or not. Let's set it up to say like about 2 megs on the resistance range. So it's much better to do with an analog meter as well. And we go on one side of the capacitor, on the other side of the capacitor. That's actually still a good capacitor, believe it or not. Yeah, that's fine. I wouldn't like to try it at voltage, but it is actually showing capacitance. That's basically what you want to see happen. You'll see it charge like that and then go to open circuit. Let's just try and find out what that capacitor is, and we can put a new one in there anyway. I'm not going to be leaving any capacitors in circuit which are in a part of the circuit which is going to have HT on it. Basically, they will all be changed, because if this is successful with this conversion, I plan to actually put this into use in the living room so I can really evaluate it. Right, that's what we was trying to find out, was what that capacitor was. And we've got a 0.005. Let me get my capacitors. 0.00, they're 0.0047s, but they look horrible. What, forgot anything nicer? Yeah. That'll do. That's a modern 0.005 at 630 volts. I think that's probably rated at 1000 volts, but oh no, 350 volts DC, the old one. So what we will do, we'll cut that off. We'll clean up them 2 little pins there. Just basically scraping any tarnishing off them so they're going to solder easier. We could take all that off there and remake these connections, but as I've said in the past, I like to try and minimise the amount that I actually disturb old connections if possible. You tend to find out you're going to create less faults like that. So we'll use the old much thicker legs and basically use that as a wire wrap. I'll get you in on the camera so you can have a look at this in a second. Right, let me get you zoomed in so you can see what I've done there now. Oh, right, I'll get you down. Right there, so can you see? So basically what I did, I cut the old component out, bent the legs up, the nice thick legs on these old wax capacitors like that. Took the new component and I actually wound the legs round each side like that. Then we'll take some solder. Solder that in like that. There we go. Then we can just trim the excess off. Like that. And there we go, that's the new new capacitor in place. I could just pop them off to make life easier for the moment. I think I might do that actually. But we still don't have to disturb what we've just done there. We're just going to pop these wires out. There we go, that's that one off. That's that one off. We'll put that out of harm's way for now. Let me get you zoomed back out for a bit. Ooh, there we go. I've really got to get that other camera I've got set up so I've got an overhead shot for doing stuff like this. Right, there we go. I'll put that into out of harm's way for now. And turn our attention to the chassis. Right. We've got the valve out there. You've got obviously got to be sorry, just bear with me a second, folks. That's my phone. Right, okay, we're back, and in fact, multiple days have gone on since I had to break off filming then, and things have happened. I'll have to kind of do a little bit of a recap because unfortunately I wasn't filming when this happened. Basically, I come back to this, and I noticed something. I was pulling these valves out because I wanted to check them. And I noticed we should have an ECH35 here, and I pulled it out expecting it to be either an ECH35 or the BVA numbered equivalent of it, and what I found in there was that's a CCH35, not an ECH35. Now, difference in them two valves being basically it is the same valve. The C series valves are designed for series heater string, so like the later U series valves and the miniature style valves. So they're designed like a Christmas tree, set of Christmas tree lights, string one after the other, with a 300 milliamp heater. And I believe the heater voltage on these is 7 volts. And I have heard that you can kind of sort of maybe get away with them in a 6.3 volt transformer set because, like I said, these were meant to run at 7 volts. 6.3 volts is only a little bit under 7 volts. I've heard other people say it doesn't really work. You can't do it. You can't underrun the valve. Like I said, I have actually come across it a number of times in sets where there's been a CCH35 in place of an ECH35. I've always, when I've seen it, just swapped out and put an ECH35 in there. Some of them sets were working with it in. But I just thought, I wonder if that's the issue. The other thing, of course, is, was it just a mistake? Because, I mean, if you look at the print on there, CCH35 does sort of kind of look like ECH35, especially if your eyesight's not very good. Anyway, I popped an ECH35 in there. This is a good tested one from my stocks. Not a brand new one, but it is a good tested one. I connected everything back up, connected the aerial up, and the set worked wonderfully. Well, as wonderfully as an AM set works in my aerial with just a length of wire as an aerial. But this would pull in 3 stations quite well, same as little transistor set that I'll show you later. And it was working great. I thought, oh, right, that was the problem. It was just someone had subbed the wrong valve in. This is either just not happy in this set or that's tired. I mean, it could be tired. I will test it on the valve tester and see if it's any good to go in stock as a good valve, or it can go in my scrap valve bin. But yeah, so it was working great. So I thought, right, we'll get up, we'll set the camera back up, and we'll fill that part of the thing. Just as I said that, there was a pop, and the whole workshop started to fill with smoke. So I quickly switched off and left the workshop, and that was a couple of days ago, and I've been really busy, and I'm basically just getting back to it now. I know what's happened because I did lift the chassis. Well, we'll disconnect this speaker and get the speaker out of the way. I just had that roughly hooked up while I was playing with it earlier, and if we lift up the chassis, let me get you zoomed in a little bit. You can see all the spew all here, and those electrolytic capacitors there, the one at the back there has blown its top. Now if you remember before when we was working on this, I felt these capacitors and they weren't even getting warm, they were fine. Obviously just didn't like working again, and like I said, it weren't getting hot or anything, but it just decided my time is up, and it blew and it has spewed its guts everywhere. So that's basically the first thing we need to do today. Before we can go any further, I need to clean this mess up, and we've got a mess really. I mean, it's nothing that's going to destroy anything. It was just an electrolytic capacitor blowing its top, but it's kind of gone everywhere. This must have leaked out a little bit as I've left this, because it weren't quite this wet and icky when I left it. So what I'll do, I will think I've left my kitchen towel in the kitchen, strangely enough. I will pause the video now. I will go and get some stuff to clean all this mess up, and then we will have a look at pulling them caps out, doing some work round there, and then we'll see how it plays then. At the moment I'm not actually thinking about changing any of these waxes here, because I've checked them with the radio running and none of them are leaking, and when we do the FM conversion, to be honest, they're all going to be redundant anyway. The only thing we really need to consider is round, you know, round the audio output stage there for then, but we will need good smoothing cans, and obviously we can't leave those in circuit in the state that they're in. So we'll work on that first. We'll do a clean up, we'll work on swapping them out, and then we'll have a go at giving it another play. So back in a sec. Right, okay, I've got some paper towel, I've got some elbow grease here, so hopefully we can clear this mess up. That'll do. And then we can look at changing these capacitors. Get it off my workbench first, and then we'll have a look at cleaning the actual radio. Yeah. I made a nice clean spot on my bench now. There we go. That's the worst. Look at that. Yuck. And go straight in the bin. Right, let's have a look at how much. Actually, right, first things first, let's remove these valves so we don't do any damage. Let's get the rectifier out. In fact, let's pull all the valves, and then we're being on the safe side, so that's the output valve out. That's the AF39. That is another one that I swapped out. That's the original, which is a 247. There, I haven't tested that on the valve tester. It's just that that is a good known tested valve. That was basically where I was getting up to. I was going to try and swap that back and see whether that made any difference, whether it was that was bad, or whether it was the fact that we had a CCH35 in there. But like I said, that's when the capacitor went pop. Let's get all valves out. These are spares. So that's the CCH35. I need to test that in the valve tester and see if it's any good. Put that over there for now. That's a CV 1053. That's basically the military version of the EF39. Right, we're a bit safe for that. Let me get you zoomed out a little bit, I think. There we go. Right, so we can work on this and we're not going to worry about breaking a valve. Because I mean, some of them valves are actually going to be quite expensive if we broke them. Right, let's get all this spew off here. I'll just give it a quick wipe down with the elbow grease. It does a really good job of just breaking the muck up, that stuff. Yeah. There we go. And get this capacitor block out, and then we can have a look. And it'll give us a bit more chance to clean that up a bit better, I think. A screw up there, a screw up there. Lovely, they're underneath the mains transformer, so they're going to be fun to get out, aren't they? Let's get that unplugged. It is unplugged from the other side, but plus I want to change that mains lead anyway, because it's a bit on the short side, that really. Right, we want to get that screw out and that screw out. I can get hold of them with something like that. No. If I can get on, possibly. Let's find some sockets that'll fit. We might be able to do it that way. That's too small. We get in with that. These are going to be quite tricky to get out, I think. Tell you what, chaps, let me have a think how I'm going to well, in fact, if I got that out first, I'll probably get a better grip on them, won't I? Yeah, that'll work. Silly me. If I unscrew this, oh, and there was a grommet on the back there, but it's just completely disintegrated, so I'll have to replace that for the mains wiring. Come on out. There we are. Oh, bloody hell. It goes all the way. Take that out. There we go. Now we've got a bit more access in there to get to them two fixings. That won't fit it, will it? Oh bloody hell, yes it does. Of course the screw on the other side's turning. There we go. We can hold that still. Unfortunately, the other side of that screw is underneath the mains transformer. I really don't want to have to take the mains transformer out if I don't have to. Right. Get that out. We can get this. I don't need to hold that anymore. Of course the other side's spinning now, so we can get the screwdriver in there and hold it. So otherwise I'd have to be taking the mains transformer off to get to them. Right, there we go, that's out. Should be able to get this bracket off. There we go. Here's the capacitors in question. I'll try to work out if these are original or not. They're 8 microfarads, so they're 8 microfarads each. I wish I could see a date on them. Right, let's get them out of there. A nice grounding tag there we could probably reuse. Get them out after. can't see any date on them. That's the only shame. I wish I could figure out whether these have been replaced once already or these are the original capacitors for in here. I've got 450 volts peak working, 550 volts surge. They're not seeing anything like that. They're seeing, you know, 250, perhaps 280 maybe. Them two looks like they're still actually alright. I mean, we won't reuse them, we'll change them, but they do actually still look like they're okay. This is the one that blew its top. Yeah, they're all the same, they're all 8 microfarads. Let's cut him free and we can get him out and have a look. Right, there we go. So this is in a different part of the circuit completely. I wonder if that's why it went pop. There we go. It's exactly the same as the other two. It's just it's spewed its guts, and it did go. Like I say, it went with quite a pop, and it filled the workshop with smoke when it went. So yeah, that wasn't fun. What I might do actually, I might have a little bit of a clean up off camera around here, see how good I can get that, get as much of that capacitor spew out of there, and we'll come back when we're ready to put some replacement capacitors in there. So back in a sec. Right, okay, we're back, and as you can see it's looking a lot cleaner in there. I've actually got it upside down because it was a lot easier to work. I haven't got all the spew off, there's still some down this side here that I just cannot get off, but it's looking, you know, a lot better now. We've got it off all these components around there. And all I did was hit it with some cheap contact cleaner like that, and then towel and clean it off, and that did the job. Now I went and had a look for some replacement electrolytic capacitors so we can change these 3. Now unfortunately I've not got anything exactly right for that. What closest I've got are these. Now these are some I've pulled off an old switch mode power supply or something like that. These are 10 UF at 400 volts. They're a decent brand, they're Nishikon, and these have been tested and they're perfectly good capacitors. Low ESR, they're absolutely fine. The trouble is, like I said, they are very small. They've only got small short legs on them. Value wise, I mean, these are 8s, these are 10s. 10 is the closest modern value you'll get to these 8s. Alright, these are rated at 450 volts, these are rated at 400 volts. I know the rule of thumb is you never go down in voltage. Truth of the fact is, we've measured the rectified DC voltage coming out of the rectifier. The highest it is 280 volts. 280 is a lot lower than 400. These will be absolutely fine. The trouble we have is finding a way of mounting all this modern stuff like that neatly in here. And what I've got, now I haven't got very many of these and they're rather expensive to buy. I do tend to keep them for use in record players and things like that, for terminating, you know, the phono connections in record players between the deck and the amplifier. That's what these are actually meant for. That's why you've got like left, right and ground basically, but it is a nice little standoff. Essentially what I'm going to do is mount a couple of the capacitors on here, using that as the ground, so we can basically mount it down there, have it nice and neat. And then the other capacitor, the one that had spewed its guts, this one over here, it actually goes from a connection down here to over there. So what I think I'm going to do is basically get some long leads on one of these and actually mount it over there out of the way. I think that'll look fine, it'll work fine, and that means we can do away with all these capacitors here. So what I'll do, I'll have a look how I'm going to make this up. I'll make that up so it's ready to install, and then we'll come back and we'll have a look actually putting that in here and changing that capacitor out with something a little bit neater over there. I have to be super careful around here because there's lots and lots of very thin wires, like from this coil over here, and they're basically just like strung through, and you break one of them and you're in for all kinds of trouble trying to sort that out. So I've got to be super careful as I'm doing this. Anyway, I'll have a look what I can do with that, and then we'll come back when I'm ready to install something in the set. So back in a sec. Right, okay, we are back, and this is what I've come up with. So basically I've took two of those capacitors and I've soldered them, so we've got one positive there, one positive there, and then the two grounds strapped together that go to there, and basically that's how the old capacitors were in here, as you can see, with the ground lug on the end there. This capacitor, the one that actually blew, is in a slightly different configuration, because that goes to the centre tap on the mains transformer there. I had a look on the old circuit diagram here, and it is C16, which is that capacitor there, and the ground of that actually goes to the centre tap on the mains transformer. What I've done is took the other capacitor that I had and I've just added some extra lead to it and put some heat shrink on it, and as I've said, I'm just going to put that actually in circuit over here rather than where it was originally over there, because I think that'll be a neater solution with these tiny little replacement capacitors. So might as well get on with that, get that done. It does mean we're going to have one of these standoffs which isn't going to be used anymore, so what I'll do with that, I'll put the washer back on it, and let's find the nut for it. Oh, the nut for it's still stuck in the end of there. Let's see if we can get it back on. Ah, got it. Right, now this is going to be a little bit tricky. I'll basically put it under there, hold it up, we can spin that on and tighten it down. There we are. Now hopefully I can try and grab this one. There's another nut stuck in the end of my little nut driver there, which we need. Just gonna hold that up like that. There we are, lovely. Right, what I do need to do, that hole there is ever so slightly too small to comfortably go on there like that. This is going to have to go on, hopefully we've got enough room. Yeah, we'll have to, yeah, we're not going to fit it on that. I should have put it over there, shouldn't I? Damn it. Yeah, it'd have been fine over there, not over there. Right, just a minute folks, I'm going to swap that over. Right, okay, that's sorted. What I've done, I've just reamed out that hole there slightly to slightly enlarge it, and hopefully we can then stick that on there like that. That's better. Let me get my screwdriver underneath to hold that up. I think we should be able, yeah, there we go, that's gone down on there now nicely. Let's get the washer on top. We'll get the nut on it, get that secured down. That's got to be nice and tight because that's basically how our ground connection works for this. Well, it's exactly how the old ground connection worked, so we should be good with that. Now what have I done with that nut? Oh, nuts. Oh, it's there, for God's sake. Why didn't anyone tell me? Right, okay. Right, we'll tighten that down like that. Should be able to tighten that in place. That's where you need 3 hands. The problem is you can't, unless you take the mains transformer off, you're not getting to that screw under there, so it's a case of holding it with the screwdriver so it doesn't fall out. try to hold that so it doesn't move and tighten at the same time. There we are. There we are. I think that should be fairly good. That's fairly tight there now. A little bit loose. Oh no, that's just the board. The actual fixing itself's nice and tight. That's just the board flexing on the connection there. So that's fine. What we need to do now is connect basically those capacitors there to that, and I think those original leads should be long enough. But before I do that, I think I'm going to deal with this one here. Now we've got an original leg there, so I think I'm going to take that off, solder that on, take that original wire off there, solder the other side to that. So basically we're eliminating all that and that, and it should be a lot neater, that. Right, let's have a look at getting that off there. I normally advocate the J-hook method, but I think in this instance this is going to be better. Let's see how that's been connected on there. Get that loose. Some snips. Let's get some better snips. Right, there we are. So I've got the old wire out of the hole, so I've actually cleared the original hole down there. I don't know if you can make that out, but basically where the wire was down on there, I've actually got the hole cleaned out because I want to put this capacitor . We'll thread it through. We'll drop that in there like that. We'll bend that round. So basically we've got a mechanical connection just like the original. There we go. I'll solder that in place and then we can deal with the other side and get the other side onto there. Okay, I'm happy with that. We'll pull that, basically want it in fairly tight. There's plenty of lead on there, lovely. Right, because we've got a few wires already on there, I think what I'm going to do, I'm going to cut that off and basically just twist round and solder on. I think we should get a decent connection there because there are a few wires on that lug. We'll snip that off and take the new wire, twist that round there. Oops. There we are. We basically twisted the extended leg. I'll bring you in once I've done this just to have a little bit of a closer look, but okay. That's okay there. We'll solder that into position. There we go. Little bit of excess on there, we'll just snip off, but apart from that, that seems to be a decent connection there. There we go. So that's that new electrolytic in there, and that's because it's so light it's not going to move or anything. If you can see, we've got it down there. That's fine. That's the one that had blown its top. Let's deal with these two now. So that one, I think we're going to have to put a new lead on. That's going to be a little bit short. The other one, I think the other one will actually get away with. I think we might just be long enough. Let's desolder this and see if we can. We really need to save all the length on this if we're going to reuse this piece of wire. The other one is definitely going to be too short, so we'll have to replace it, but I have a feeling if we're lucky this one might just be long enough. There we go, that's free. Clean that off. That's going to go to that capacitor there. It's just going to be long enough. Especially considering we can just bend that way a tiny touch and then we can get that. Yeah, that's going to work quite okay, but we just want to insulate, obviously, because this is going to have a couple of 100 volts DC on it. We don't want to leave it uninsulated like it is there, so we'll take that extra piece of insulation from there. This is just off the capacitor we've already replaced. Let's just cut that down a touch. If this doesn't work, I will have to use a bit of modern insulation, but if I can use this original stuff, it'll look nicer. The problem is it's a rubberized insulation with a cotton covering over it, and although the cotton covering is actually in quite good condition, the rubber inside, it's going a bit hard now. No, I'm going to break the wire if I try that. I'll have to use a piece of modern insulation over that. I'll cut a piece of that. Stick that over. There we go, that'll work. Let's put a little hook in the end of that wire. Bend that over the eyelet. Basically just made a little hook on the end and close the hook up. We'll have to tighten that up. Oh no, it's still nice and tight there. It's just like I said, it's just that bit of paxilin that's moving rather than the actual ground connection there, but I will make sure it's tight when we've finished all this. But that's all nicely insulated now. Let's solder that in place, and we've got one more to go. And we're back to where I was, seeing whether it was those valves that were causing the reception problems. Alright, that's soldered in place. Kind of looks ridiculous with those two tiny little capacitors down there if you consider those are the originals. But I mean, so that's the thing with modern components compared with the original components. Right, there's no need to desolder it there because that wire is definitely going to be too short. We're going to have to replace that. So we can desolder it from there. There we go. And I may actually just test them just for, I mean, that looks pretty manky as it is. The seals aren't good on them. It's all corroded on that side there. That's starting to fail. These aren't good capacitors. I wouldn't want to keep these in circuit, even if that hadn't have blown. I'd have been changing these anyway, just because, like I say, I have got a plan that if this actually works and this conversion's good, I'd like to use this in the living room as a main set. So yeah, they'd be going anyway. The only thing I'll salvage there probably is that connection, that connector there, because those are really handy to keep. I'll throw those to one side, and that'll probably go in my spare bracket box if I don't. No, I can't really put it back on because I'm using that point there as that ground point. Right, so we need a piece of red wire ideally to replace that with. I mean, obviously it doesn't have to be red, but if I've got a piece of red, I'll use a piece of red. Let me have a look around and see what I've got. Oh, that looks just about perfect. Oh yeah, that's just right, that. That should be just, I mean, okay, it's not modern, it's not vintage wire, but at least it's the right colour and it's a decent gauge. It's a good enough gauge for what we want. So let's go from there to there, about that long I should expect. And we'll get that stripped. Alright, again, if we make a little hook in the end, we can bend it round like that. I need to tighten that up a bit. There we go. Bend that in place. We've basically hooked the wire round first, and then we'll solder it in place. There we are. And then that just has to go up and solder onto there like that. In fact, I wonder if I can clean that hole out a little bit more, make my life a bit easier. Where's my solder sucker gone? There he is. It's a lot better. There we go. I think we can get the wire fit. In fact, it's not going anywhere. Just trying to get as much old solder off this pin as possible so I can get the new wire through it easier. There we go. That should work. There we are. Enough to push that through. Just bend it over like that. We can solder that in place. There we go. Right. Yeah, that's okay. Smooth that round like that. There we are. So there we go, we've got them three capacitor's changed now, and I'm hoping, like I said, that that wasn't really the issue anyway. The issue was the fact that that valve was wrong, that we had a CCH35 in there instead of an ECH35. Because as soon as I changed that, I'm not going to put that bracket back there because I will change this mains flex. But for now, let's throw it back over. We'll get my all the valves back in it. We'll get the aerial connected back up. Where's the other end of the aerial? There we go. We'll get the aerial all hooked back up, and we will see if we can get some signal out of it, because it definitely got something earlier. Right, let's do that then. We've got all the valves here, haven't we? So we've got our output valve there. Let me get you zoomed out a bit. There you go, you can see more what's happening. We've got our EF39. Okay. Where's our ECH85? There's our ECH85. So like I said, that's the valve that we changed out. There we go. And we need to put the top cap back on that. We'll put our rectifier back in. We'll remember which way around it goes. Come on, which way around do you go? There we go. So that's our rectifier back in. We need to hook the speaker back up. Let's get that back over there. And we'll have to put the limiter back in, won't I? Let's get that back in, but it's not switched on and the limiter is not actually plugged in over there. Right, let's get the speaker. Now when I was testing earlier, I did just literally have the wires just touching. I think I will just tack them on, just for a little bit of more safety. I'll solder these back on properly when I finally put it back in the cabinet, but just for now I'll just tack them on. So I just had them resting around the terminals when I was playing earlier, and you do have the risk of them just dropping off when you do that, but there we go. Like I said, I will solder those back on properly when it goes back in the cabinet, but for now that'll be absolutely fine. Just for testing, we'll connect the aerial up. I have actually put a proper aerial connector on because I was having problems getting that to connect. Let's just take that out in a minute. Right, that's the lamp limiter connected. We're off on the switch there. We're in with the lamp limiter, even though it's just off shot. Let's switch that down. Let's switch on. The lamp limiter did just come on and flash, and it's just glowing nicely now. In fact, it's virtually not on now. It's lighting up a little bit as them capacitors charge and as everything warms up. A bit of hum. Let's see if we've got any stations now.
That kind of situation, really anything can happen anyway. That's what makes it so exciting.
There we go. That's our local Asian station, which, to be honest, you certainly couldn't pick up on that TRF set. You need something that's reasonably sensitive to actually pick that up. We weren't getting that earlier. That actually seems to be all picking up at the moment, but... Oh, there we go. There's a local torque state. In fact, I'm still on reduced power because of the limiter. Let me switch the limiter out.
Well, let me tell you, one of my best results ever at Switch, when we went there, what was it, 1-1 in the first leg, we went in the semi-final to go.
Basically all picking up is like switch mode interference and things like that. Let's see if we can get a better connection to the aerial. I've actually got the end of the aerial connected to my drawers.
Now this is before your time.
There we go.
Do you know about the glass?
In fact, let me try turning my soldering iron off. Let me try turning the light off above my head. You see if that'll make any difference. I were getting more earlier, I have to say. Try the other aerial connection. Oops. No way, not very sensitive at all. I'm wondering if someone actually has fiddled about with the alignment on this, being that, like I say, someone has fiddled with it before I got it. Our front end's certainly working quite nicely now anyway. There we are. So we've got Torque Sport there. There's our Asian station. Yeah, there's our Torque Sport. And that seems to be about all we can pick up, really. Let's turn off now. Just for a comparison, though. I've got this. Oh, hang on, let's see if we can get hold of it. Ah, there it is. Now, this is something I picked up at a car boot, I think it was last year or the year before. And I was using it as a garden radio until really, there's not much, like I said, there's nothing to listen to anymore, but this is about as good as you can get in here, yo, sensitivity wise. I can pick more up on this on the AM than I can on any of the valve sets I've got. That's that Asian station again. If I tune, you can hear all the interference.
For more information on our no-win, no-fee service, text DRIVE to 60777. That's
Talk Sport. Oh, sorry, there's Talk Sport. And we've got
regulated Luther.
I think it's Radio 5 Live, that. That's it. And a lot of interference. That is all we get on medium wave around where I live. And I said this is about as sensitive a AM set as I've got.
He misses his first serve.
Tenacious sports conversation fueled by
You can hear all the interference in the background.
Oh, yeah, I think you might be my favourite so far, mate.
In fact, we seem to have lost our Asian station, unless it's... There it is. So as you can see, you know, I do struggle with reception the best of times. This is... Oops. Knock you then. This thing is really, really, really struggling. Let's just switch back on once again. And these were never designed as, like, you know, monster radio receivers. They were really more designed for your local... There it is. So there's our Asian station again. And that's about it. I'm sure I've connected up a great big long wire aerial rather than just this little... I've probably got about 3 meters of wire with the end of it just connected to my metal shelves down here. I'm sure if I was to connect it up to a much longer longer wire aerial, I would get a little bit better reception. But that's the whole thing with AM round here. I'm fairly confident, to be fair now, that the audio output section on this is absolutely fine. In fact, judging at the circuit, if we ignore the whole radio section here, like I said, we've got the West Texter there, that's the detector. So we can ignore pretty much everything from that side for what we're intending to do with this radio. We really are only concerned about the rectifier, which we know is okay. We know that the voltage output on that's fine. We know the output transformer's alright, we know the speaker's alright, we know the output valve is okay. We've got C14 there, which is really the only capacitor I think we're really going to have to be concerned about. And in fact, if we could even go, if we disconnect there and we connect in this side of C14 with another capacitor, we can ignore everything on that side. We've already changed C16, C17, C18. Those are the electrolytics we've just changed. C13 there even, which is the electrolytic, that wax paper electrolytic that's across the back of the chassis. It's not going to really be in circuit when we use this for the FM conversion. All we're interested in is this part of the circuit here. So I'm not really worried about any of this. I would have liked to see if I could get it to play a little bit better. But you've seen how a good AM radio performs in my area. And I can't see the point of hooking it up to a big... In fact, I don't even have a big, long, really big, long wire area like I used to have. I used to have one that went from the house right down the garden to a pole at the bottom of the garden, from when I used to have a lot of 1920s TRF sets I used to play with. Because basically if you're playing with them, that's the only way you can really get a decent reception round here at all, is with a proper long wire aerial. And it was very good for sets like, messing with sets like this. I used to use it with my R155 military receiver, which I use for listening on shortwave and stuff like that. It was very good for that. But that come down a few years ago, and I've never been inclined to replace it. And as I'm moving house, hopefully as soon as I can do this one up and sell it, I have no inclination to put it back up at the moment. So yeah, I'm reasonably happy so far that we've got this into a state where I can actually do the FM conversion on it. So that's probably what we're going to do in the next video, to be honest. Said now I'm happy with the audio section on this. I might spray a bit of cleaner in that volume control, because that volume control is a little bit scratchy, but I think it'll work for our purposes. The rest of the set, really, like I said, we won't even be using these two valves, so it doesn't matter that that had a CCH35 in it. We won't be using them. What I'll probably do, just for, if I decide that this is really good and I want to keep this, what I'll probably do just for aesthetics is put two Duff valves in there, and I won't even connect the heaters because they're not needed. What we're going to have is just that. Plus, that means that we're putting less strain on the old mains transformer as well. So we're not going to be using valves that we're not going to be used. We'll just put something in there for display. Because they're covered valves as well, it doesn't even really matter if they light up or not. Just if someone looks through the back of the radio, it will look authentic. And there's loads of room back here or under the chassis to actually mount the PCB, where it's I might even consider mounting it up here like that. I don't know, I might mount it under the chassis. We'll think about that. We've got loads of room under the chassis, we've got loads of room on top with this, to be honest. Anyway, I'm going to leave it there for now. Like I say, really in this video I was just really attempting to see, one, how well will this thing play. I'm not going to go to the trouble of changing all them capacitors in it for the sake of the fact that I'm not going to use this as an AM radio, and there's very little point. None of them, strangely enough, when I did test them going through the circuit, I tested for your HC voltage on one side, tested on the other side, and I had nothing on any of the ones that I tried, which was everything really that should have had HC on one side and a DC blocking effect on the radio. None of them were leaky at all. So I mean, that's a good thing anyway. Right, I'm going to leave it there for now because I'm probably rambling and ranting a little bit now. Hope you enjoyed watching me fiddle about with this. Like I say, in the next video we will actually get to putting the FM conversion board on this and seeing how it performs, and we'll get it all back in the case and looking nice and what have you. So I will say, hope you enjoyed watching that. Thanks for watching and goodbye.